everyone. So the second part to the video will be a continuation of what we did in last week's class during week 4. So we started in that week solving. So I'm on page 32 of your notes, and this is what we had covered in class. So just recapping that, you should already have these notes. But we are solving, and so one of the things we discussed is what's the difference between solving a function and finding the zeros. So again, finding the zero means if you are finding the zeros in that calculator step where it says second trace and it says 0. I'm finding my calculator. Then when you are choosing option 2 for zeros, those are x-intercepts. And in a graph, all x-intercepts have a y value of 0. So what we did is in the first section, we learned that f of x is y, so I just replace y with 0. And so I just go about solving for x now. What number, if I put in for x and do the math, will make my y value 0. And again, that's what's known as finding the zeros. So in this one, I told you that y, or g of x, was 15. It went in place of there. We did the math. Okay? And then this was just solving, distribute, combining some like terms, getting x to one side, and then going from there. So I don't know if I finished this problem, but real quick, I'm going to add 20, and then I'm going to add 20. And so when I'm done, I get 16x equals 4. And then after I divide, I get 4/16. So I do remember talking with the silver group, my, what day would that be, Thursday group, that you can leave your answer like this. You can simplify it into 1/4, or you can turn it into a decimal. And one thing that your calculator does for you is it turns your fractions. So if I divide it, I get the decimal. But if I press this math button here, so right there, it will actually give me the opportunity to turn it back into a fraction. So I choose option 1. And it's saying you want me to take this answer and make a fraction. And if you do that, it will give you the simplified fraction. So for this 4/16, 1/4, or the decimal, which you can also see on here is 0.25 or 25 hundredths. All right? So after solving equations, in one group, I got a little bit more started in solving absolute values. So if you are in the red group, I'm going to... we already went through this problem, and if you're in the, so you're going to fast forward till you get to the problem next to it, and then both groups, we're going to talk about this problem. So even red or silver, again, one class we did this, we're all going to do this one together, and we're all going to do this one together because I kind of left it hanging there, and I don't want to do that. So I want to come back to that. So let's pick up where we left off. So one moment. Okay, again, so this first problem, the 2x minus 5 equals 9, the red group got this. So just fast forward until you see me writing under here. And then, again, we'll pick up that last problem in just a moment. So first, I just need to remind you of what an absolute value is. So this absolute value means how far a number is from 0 on the number line. So if I ask, what two numbers are a distance of 5 from the number line, from 0, well, if I go 5 this way, then I'm at 5. But I can go a distance of 5 in the opposite direction, and then I'm at -5. So the idea is if I take the absolute value of 5, I'm actually just saying how far is this number from 0 on the number line, and it's 5 units. Or I could ask the same, how far is -5 from 0 on the number line, and it's also 5 units. It just happens to be to the left versus to the right. So when we solve absolute value, we want to make sure that whatever we take the absolute value of, it technically ends up as a positive number. So where you see C, there's this extra condition at the end where C is bigger than 0. That's just ensuring that we're working with a positive number. So when you get a problem, you're actually going to be making 2 equations from it. So like this problem. So basically there's some number that if I take it times 2 and then subtract 5, I can take the absolute value of it and get to 9. So I could take the absolute value of 9, maybe I do the math in here, I get 9, and then I get 9. Or I could do math in here and get the absolute value of -9, because that will also give me 9. So when I solve, I'm going to have to solve two problems. So here's one, and then here's the other. So some common mistakes. People know that they're going to have two problems here, and so they want to switch positive versus negative, which is what you want to do. But anything in these bars, they are protected, so you can't touch anything. So people will do this equation right, but when they rewrite the other one, they'll change the 9 into negative, which is what you want to do, but then they're going to change the subtraction into addition, which is you don't do that. Anything in the bars stays intact. So you're going to have two problems to solve. The steps will be the same. The results will be different. So here I'm going to add 5, and that gives me 14. And then I'm going to divide by 2. So one of my answers is 7. And then here I'm going to add 5. But this time when I add 5, I'm adding it to negative 9, and that gives me negative 4. And then when I divide, I get negative 2. So two answers will work for this problem. So just to show you, I'm going to clear this out. So checking my answer, I've pressed the math button, and I'm going to scroll to the right to number, and I'm going to choose this absolute value. And if I take 2 times my answer, which was, one of them was 7, right? And then I subtract 5, and I get out of those bars, I should get 9. And then if I do this again, so math, I'm going to scroll over to number, take 2 times negative 2, and then subtract 5, I should get 9 as well. And again, it's because when I'm done, I get a 9 or a negative 9 in those bars, and the absolute value of either number, the distance from either of those numbers to 0 is 9. So let's talk about this one. So I need this problem to look a lot like this one. The problem is on this side of the equal sign, on the left side, there's an extra number hanging out, and I can't have that there. So to get this problem to look like this problem, I'm going to add the 6 to the other side. And that's going to give me 23. So now, again, if I take some number times 8 and add 1, I could get 23, and the absolute value of 23 is 23. Or I could do that math and get negative 23 in here, because the absolute value of negative 23 is also 23. So I'm going to have two problems. So I'll have x plus 1 with the positive 23, and then x plus 1 with negative 23. Again, nothing in those bars changes. It's 8x, it's plus, and it's 1. So same steps for both problems, different results. So here I'm going to subtract 1, and that gives me 22. And then I'm going to divide by 8. And then as far as your answer goes, you can leave it as a fraction. You can also take that 22 divided by 8 and get the decimal. You could also tell your calculator to simplify that fraction for you. I'm pressing math again, and it's 11/4, and that happens because I divide both of these by 2 to get to 11/4. So what's the best answer? The fraction and the simplified fraction is really the best answer. All right, so for this one, I'm going to subtract 1, and that gives me negative 24, and then I'm going to divide by 8, and I get negative 3. So again, two answers. So I'm just going to check this one on the right. So I'm going to go to the original problem, and I'm going to first get to my math, scroll over to my absolute value, and I'm going to take 8 times negative 3, and I'm going to add 1, get out of the bars, and then if I subtract 6, like you're seeing, I should get 17 as my answer. And then the same would happen if I switched negative 3 to 3. I would still get 17. All right, so at this point, I know we set this problem up in, I think it was the red class. I think it could have been the silver class, but I'm going to do the same thing here. I'm going to move that 4 over because I want this problem to look like this problem. So when I subtract the 4 over, I get negative 15. And at this point, I'm done. This problem has no solution. And I know that in one group we set this up, and I wasn't really paying attention, and I am guilty of that from time to time. This isn't going to happen, because in our original directions of what I set up here is that this C always has to be a positive number. And the way that this is set up is if I do the math and I take the absolute value, I'm getting a negative number, and that can't happen. Once I'm done doing the math over here and taking the absolute value, I should get a positive number. I can't get a negative 15 out of it. So this one has no solution. And just be aware of that might happen, okay? All right, so from there, we're going to cover one more thing with our notes, and it's about systems of equations. So the good news about this is we're actually going to have our calculator do this work, and we started a little bit of this, but a system of equations is a collection of two or more equations with the same set of unknowns. So we're solving for x, we're solving for y, we're solving for f of x, whatever you want to call it. And there's two ways to do it. You could do it algebraically, and you did this in Algebra 1, and we'll do it again in Algebra 2. But in this chapter, we're actually going to focus on graphing it, because I want us to get more comfortable with the graphing calculator. So, we're going to graph this, and we're going to do this because f of x equals g of x. So we're going to have 4x plus 21 equaling 7 with, in parentheses, x plus 9. And the idea is, I know I could solve this. I could distribute and do what I did, over on these pages here. Okay? No problem. But since we already did it there, this is technically a system of equations. One equation, one equation. I want to show you the calculator. So you need to go to your graphing calculator, and you need to go to the y equals and clear out any equations that you have. And what we're going to do is put one of these into y1, and we're going to put the other one into y2. And again, you can put it into any of the y's, but they got to be in different y's. So I'll do 4x plus 21, and then 7, and in parentheses, I'll do x plus 9. Again, your variable button is this one. And then the first time we ever graph something, we do zoom 6. So zoom 6, and I'll be getting two lines. So here's the 4x one. There's the other one. So these two are meeting somewhere. The problem is we're not seeing where they're meeting. So if you notice, as they go up, they're actually getting further apart. So where they're meeting is somewhere down here. So I need to get my calculator window down to here. So what you're going to do is you're going to press window to adjust the window. And I want to go left, and I want to go down. So x min and max, that's my left and right. So I need to go a little bit further left. So let's just try negative 20. X max, I don't need to adjust that. That's the scale that I would see, that it's going up by 1s or 2s. That doesn't matter. Y min, so I need to go a little bit lower. So instead of being at negative 10, I'm going to try negative 20. And then the max, how high up it is, that doesn't matter. And then the scale, that doesn't matter. So take a moment, look at your calculator scale, what I did, and remember, these have to be negatives, not subtraction signs. And now that I've adjusted my window, I'm going to hit graph, and I hope I see them. Okay, I'm close. I just actually need to go further down. So I'm going to go back to my window, and since I need to go down, I need to go to y, and I'm just going to really change it to negative 40. I'm not going to bother with negative 30. So I'm going to hit graph, and some of these graph slower than others. Sorry if yours graph slow. All right, great. I can see that point of intersection. That's all I need. So now to find that point of intersection, I'm going to hit second trace, and I'm going to go to intersect. Now, if you're using your phone, first you got to get the graphing calculator, because the phone, the directions are a little bit later or different. But what I want to do on the calculator is just move close to where I think it is, and then I just have to hit enter 3 times. If you're using your phone, you have to go to exactly where you think it is, and it's actually going to say left bound, and then you have to hit your left arrow and trap it, and then you go back to where you see it, where you think it is, because then at the top it's going to say right bound, and you have to hit your right arrow, and then it will give it to you after you hit enter. But this is one of the nice things about the graphing calculator. This actually is less buttons. So I just go to close to where I think it is, hit enter 3 times. 1, 2, 3, and there's my intersection. So I got an x value and a y value. So if you look at what we're solving for, I actually only want the x value. So I'm just going to say, you know what, my answer is negative 14. And again, that's just what it shows me on the calculator. So let's try another one. I'm going to have this one and this one. So it's saying that h of x equals g of x. And I'm going to go back to my y equals. One side will be y1 and one side will be y2. Again, the whole purpose of this is with the graphing calculator. So I'm going to clear these out. And I'm going to do 2x minus 3. And then the other one is 1/3. So for the fraction, you have to put that fraction in parentheses so your calculator knows that 1/3 is your fraction. And then to get those absolute value bars, you press the math button right down here. You scroll over to the NUM, and there it's going to appear. So this is the newer operating system. If you have the older, like an 83 or even some of the older 84s, it'll say actually ABS with parentheses. And then in parentheses, you put x plus 2. Again, if it's the older operating system, you have to close your parentheses. The rest of us, we arrow out of it, and then I do -5. Again, the first time you graph, start with zoom 6. So we should have a line. This is a line. And anything with those absolute value bars, that's a V. So zoom 6. So there goes my line. Here goes my V. And it's only meeting once. I mean, there's no way that this line, if it keeps going, is ever going to hit this part again. So to see this point of intersection, I choose second trace. We choose option 5 for intersect. Again, just move your cursor close to where you think it is, and then hit enter 3 times. So I get -0.8 and -4.6. Again, I only want the x value, so that's all I'm going to write down. So -0.8. All right, let's take a look at a word problem, and then I think we're done with our notes. Yeah. Okay, so we got 2 cable providers. We got Uptown. They charge each customer $120 for installation plus $25 per month for programming, and their competitor charges $60 for installation, so less, but then they charge more per month. So after how many months will Uptown customer and Downtown customer be paying the same amount? So let's say we have Uptown. To get Uptown's bill, I would pay the $120 plus $25 every month. And then if I have the Downtown customer cable group, it's $60 for installation plus $35 every month. And what I want to know is, when will this bill and this bill be the same? When will they equal each other? So I want to know, when will Uptown's bill equal Downtown's bill? And now I'm just going to swap this out for U. And I know you can't see that, sorry. And I'm going to swap this out for D. And again, this is totally fine to just solve for X on paper. You know, move the 5X over, move the 60. It's actually much faster. But I am going to show you on the calculator. So I'm going to put in 120 plus 25X. And on the other one, I'm going to do 60 plus 35X. And again, I always start with zoom 6. And I don't know if we're going to see it here. So there's one. There's the other. So this one's really hard to see what's going on. They almost look parallel, but I think they're actually getting probably a little smaller up here. Okay? So let me show you a different way. So instead of trying to adjust the window, right, what I'm going to do is try something else. I'm going to try what's known as zoom fit. So I'm going to pause it for just a moment and come right back. So instead of adjusting the window, because this, it's really hard to tell where these are meeting, there's another option, and it's called zoom fit. So if you press zoom, and if you scroll down, it goes, 6, 7, 8, 9, and then it starts with 0. If you press zoom 0, it will do zoom fit. And so I'm going to press zoom 0 or just hit enter. And your calculator is going to do the best job it can to give you the picture you need to figure out your answer. It's guessing that you want to know this point where they're meeting. And there it is. I didn't have to adjust the windows. So zoom fit is a nice option. It doesn't always work. So now to find this, I'm going to hit second trace, choose intersect. Again, I just want to move closer to where they are. So on the calculator, hit enter 3 times. On your phone, once you get to where you think it is and it says left bound at the top, go left a couple times, hit enter. And then when it says right bound at the top, go back to where you think it is, and then hit enter. And then I think you don't have to hit enter again. I think it will say it, but here we go. So this point of intersection is 6 and 270. So again, what are these different amounts? So after how many months will an Uptown customer and a Downtown customer be paying the same amount? Well, again, I'm solving for x. X is the month. So as it turns out, in 7 months, right? Oops, you can't see that again. But then the y actually is a good number to have too. That 270 is how much the bill is. So after 7 months, my bill's 270. And after 7 months here, my bill is 270. So if I'm going to resume cable service after that, who would I rather stick with? I'd rather stick with Uptown Cable, because then after every month I'm only paying $25 worth versus $35. So this saved me money in the end, or in the beginning, but in the end, this group is the better saving group if you're keeping cable for 7 months. And most of you don't even have cable, you just use your phones. All right, so what is the practice? So the practice, you've got page 35, right? So you are solving. You've got the system of equations. Again, the ultimate goal is try this with your graphing calculator. This in y1, this one in y2. This in y1, this in y2. These are simple enough that if you do set them up like this, you could solve them because they're no different than these problems up here. But the main focus is graphing calculator, all right? These are your absolute value problems. And again, these are ready to go, but this one's not. You will need to move that 5 over first so that it looks like this. And again, there's 2 problems. Inside the bars is the same, and it should equal 29. And inside the bars should stay the same, and that's a 1. That's not a bar, and it equals negative 29. Again, down here it says find the zeros. So that just means 0 should equal the equation. Finding the 0 means I'm asking you to find the x-intercepts. And then the problems, once you do this, excuse me, mimic these above. So first you're going to have to move the 10 over and then the 2 over to get it to look like this. And here you're going to have to move the 115 over. So let's set this one up a little bit. Because again, I want it to, whoops, that's supposed to be a 4. I want it to look like problem 3. And then I'm going to divide the negative 5 over. And when I do that, I get 23. And now this problem will turn into this problem. So I'll have 3 plus 4t equals 23, and I'll have 3 plus 4t equals negative 23. So what I'd like for you to do now is this page, just page 35, and then perhaps we will do this one in class, or maybe I'll put it as part of like our warm-up when we see each other. So I'm just going to ask you to actually just do page 35. That's it. I know it's a lot, so good luck, and I'll see you later.